Hey guys, this is Dr. Cadell and this is the Activity Series Lab. The idea of this experiment is we're going to determine the relative activities of a series of metals. And so first thing is, what do we mean by activity? In this sense, what activity means is the ability to release electrons, to be oxidized. And so what we do is we combine a metal and the aqueous form of the ion of another metal, and we see if they react. If they do react, we know that if we do see a reaction, we know that the metal that was in its solid form, not an ion, released electrons to the other metal, and that means it's more active than that other metal. So all of the reactions we're going to do today, guys, are what we call single replacement reactions. Up here are two examples of single replacement reactions. In the top one here, this says that solid sodium is reacting with aqueous gold 3 nitrate. And if it does happen, we would get solid gold and aqueous sodium nitrate. So if this reaction does happen, what that tells us is that sodium is more active than gold. Here's why, here's how. This is an ionic compound, and we know in this ionic compound, gold is the cation, and it has a positive charge, actually a positive 3 charge here. Over there on the other side of the arrow, gold is just by itself. It's metallic gold, which has a 0 charge. Just like this sodium here has a 0 charge. So if this reaction happens, gold went from a +3 charge to a 0 charge. Now the only way that can happen, guys, is if it gains 3 electrons. Well, where's it going to get the electrons from? The only place it can in this reaction is from the sodium atoms. Sodium has a 0 charge here. Over there in the sodium nitrate, sodium has a +1 charge. So we know that it lost an electron. So if this reaction happens, we know that electrons went from sodium to gold, and that tells us that sodium is more active than gold. It would be higher up in the activity series. Now this reaction down here, this is another example of a single replacement reaction with halogens. In this reaction down here, chlorine by itself has a 0 charge. Over there on the other side, it's sodium chloride. The chloride ion has a -1 charge. In this compound here, sodium bromide, the bromide ion has a -1 charge. Over there, liquid bromine has a 0 charge. It's elemental form. So if this reaction were to happen, we would know that bromide goes from a -1 here to a 0 over there. It's releasing electrons. Chlorine goes from a 0 here to a -1 over there. It's gaining electrons. So that would mean that if this reaction occurs, that bromine is more active than chlorine. So the basic idea, what we're going to do today is we're going to set up 31 different reactions and observe them to see whether or not a reaction happens. If a reaction does happen, that tells us that the metal that's in its elemental form in that reaction is more active than the metal that's in its ionic form. So how do we know if a reaction happened? Well, what we do is we have this list over here of 5 signs that a chemical reaction occurs. If we see one or more of these, then we know that a chemical reaction did occur and within that solution, and that the elemental metal is more active than the ionic metal. Here are the signs. If we see a precipitate, so a formation of some sort of solid, sometimes it just looks like the solution gets cloudy, but we can see this pretty easily. Formation of a gas. There's 2 ways that we detect the gas. If we see bubbles in the solution, that means it's gas. Sometimes if there's an odor, that tells us that it's a gas. Color change. It changes color, chemical reaction occurred. Heat. Either the evolution of heat, thermal energy, or the absorption of thermal energy. If it gets hotter or colder, that's another sign that a chemical reaction occurred. And the last one is the evolution of light. We're not going to see anything in this experiment where we see either of these happening, but they do occur in nature. And so that's what we're doing. So why don't we go over there, set up the reactions, and see what happens. All right, guys, so what you see here is all 31 reactions set up. Each label has the metal that's in its elemental form to the left and the metal that will be in its ionic form to the right. We have all the solid metal already placed out here. So for example, in this dish, we have zinc metal, and we're going to put the copper 2 ion from the solution in just a minute. We have the copper metal there and so on. So remember, what we're looking for is any sign of a chemical reaction, formation of a precipitate, a color change, bubbles for the evolution of a gas. We won't see any light, and we won't have any heat evolved. So as we add these, I'm going to add the copper solution to this row. Matt's going to add, the silver solution to the far right row? Mm-hmm. And then this column is the zinc solution, the zinc sulfate. So guys, one thing to be aware of, first of all, there are some of these where a reaction does not happen. Second of all, with the copper 2 solution, the copper 2 sulfate, the blue color that you see, that comes from the solution itself. That's not a color change we're looking for. Other stuff can be though. Likewise over here in this column, the iron solution comes with that kind of orange reddish color. That color by itself in the solution is not a color change, although when it touches the metal, if there's a color change, that is the sign of a reaction. All right, guys, so now you should have enough information by observing whether or not a chemical reaction occurred in each of these solutions to develop an activity series. There you go.